Just like this, just this kind of thing, you can write the question and then what question you have about it. Is that what you're asking about? Like, what are you asking about? You can't just be like number 15, but like, what did you get stuck on in number 15? Okay, I think this will work. All right, let's take a look at the two that are already up here while people work on getting their questions in. Oh, we'll get to that. We'll do that at the end. So we're going to do these and then we're going to do evaluations and then thank you. But we'll do the attendance thing at the end so that it's in my slides at the end for some reason. I don't know why, but thank you. Okay, so 3724. 24, find a function. This is a good one. Finding an antiderivative, that comes up a lot. And then 37, let's see what that is. 30, so much, oh boy. Oh yeah, it's the optimization. That's fine. That'll take a little bit of time. I think we'll save that for last. Let's go back to 24. Here it is. So in number 24, and please do keep adding things here because this isn't enough for us to have a good conversation today. So figure out what you're stuck on your homework or on that old final. So here you've got a function, you want to find a given derivative and value. So that has this derivative and value. So I just want to tell you what's happening here before you do anything, which is that you've got this function and you don't know what it is. The only thing you know about it is its derivative and 1 point on the function, okay? So you know what the function goes through this one place, f of 1 is 7. And then you have an equation basically for how the function changes. And if you think about it, that means if you started at this point, you could follow, this, you could learn information about how the function changes to draw what the function is on either side of this point. And this point kind of anchors it. Said another way, if your function, I don't know what it looks like, but let's say that it looks like this, for example. Well, here's another function that has the same derivative, same changes everywhere, okay? So if I took the derivative of the red function and the derivative of the black function, then they would both have the same derivative. So the reason I'm telling you this is to explain why they give you this extra point. So the information you have is the derivative of the function, but that's not enough to pin down the function because, as you know, I could add any constant to a function and its derivative would be the same. So they tell us 1 point on the function so we know which one it is. So this is a two-step problem. One is to anti-differentiate to figure out what kind of function f is. And 2 is to use that value f of 1 equals 7. So let's do both of those things. So I'm gonna write what you have to do first, and I'll give you a minute to think about it and do it. Find a function whose derivative is, and then we've got f prime of x equals 5 minus 6x to the 1. And don't worry about the value yet, just this part. And the way I want you to think about this, because this will serve you well in the next class when this is gets harder, is make a guess. Make a guess for a function f that when you differentiate it, this would come out. It doesn't even have to be a great guess. I mean, don't guess like, something crazy like the square root of x, right? Like that's clearly not going to be the answer. But guess something good. but maybe not correct. So I'll give everybody a minute to talk to your table and come up with a guess. And then how do you check your guess? The derivative, yeah, that's all. Okay, so you're going to guess a function, take its derivative, and compare it to this and see how close you were. Okay, and I'm actually happier if you don't hit it spot on if you're guessing. I don't mind if it's wrong. So just talk out loud to your group and your table for just a minute and establish a guess for your table. And then check it. I don't have
all I got.
All right, so I put a hint up here. This derivative has two pieces, and we know that when we differentiate a sum, we just differentiate the pieces. Okay, so this is really two baby problems. One is, what's a function we could guess whose derivative is going to be kind of like 5? And the other one is, what's a function we could guess whose derivative is 6x to the 9? So does anybody have a guess for a function whose derivative is 5? 5x. That's a darn good guess. It's actually correct, but we'll see in a minute. And then, can someone give me an incorrect guess for this? 7x to the 8, that's a good incorrect guess, because you think, oh, power changes, right? But if you differentiate 7x to the 8, you get 56x to the 7, right? That's not good. That's not what we want. Who can give me another wrong but close guess? Anybody have a wrong but close guess? X to the 10th. I like that. Like, screw this 6 for now. Let's just deal with the power, right? You might say x to the 10th. Like, I know that the power is going to come down. This is going to be close. Let's see what happens. You check. And the derivative of 5x is 5. The derivative of x to the 10 is 10x to the 9th. And this here is so close. But instead of a 6, I have a 10. So, and now, by the way, you don't have to do this one by guess and check, because there's actually a formula for anti-differentiating power functions. You could just use that formula. But I don't want to frighten you, but things are going to get a lot worse. Like in 232, when we have like weird things that we want to find an antiderivative of, and we're going to have to start like having strategies for guessing what that is. So I want to re-guess now. My guess didn't work, but it was close. I learned something. Well, when I had x to the 10, it didn't work. I got a 10 instead of a 6. So the trick is, I'm going to put in the 6 I want and divide out the 10 I don't want. Okay, and then put x to the 10 here. Because now when I differentiate, this 10 will come down and cancel, and I'll be left with the 6, which is just what I want. So here's my check. F prime of x is 5 minus 6x to the 9th. Correct. And again, it's possible that you're able to go right to here. Okay. If you did, let me get another color chalk. I don't know why. I guess it just seems like a good idea. It is possible for you to do this all in one step here with, sort of the reverse power rule that says that the derivative is going to be 1 over k plus 1, the antiderivative, 1 over k plus 1 x to k plus 1. You might know that formula. That's fine too. Okay, so we did part of the problem. What is the part I missed? Point. Yeah, this could be plus any number c. Oh, no, I would. So I'll say f of x equals 5x. Well, 6/10 is 3/5, right? So I'm going to start writing this as 3/5 plus c. So I found one function whose derivative was that, but there's infinitely many. 5 added plus 5 plus 11, whatever this number is, when I differentiate it, it's going to go away. So there's actually infinitely many answers at this point. And this is the form of all of those answers. And you know that f of 1 is 7. So how do I use that piece of information to find c? Plug in 1, 7 should come out. So 7 should be equal to 5 times 1 minus 3/5, 1 to the 10th. Did I get that right? Plus c. And now I have this little equation, it's all numbers and c. So what can I do? Solve for c. Yeah. So if I solve for c, I'll just put it over here. It'll be 7 minus 5 plus 3/5. I did something kind of weird there because I put the c. I subtracted these over, but then I wrote that backwards. So sorry. Whatever number this is, what is this? 2 plus 3/5, which is 10/5 plus 3/5, which is, sorry, that went off the rails there, but that says 13/5 over here. So if you guys can't see that over there, that says 13/5. Okay. So that means your function is, my memory is so bad, I can't even remember what it says over there unless I look every time. 5, tell me if I get it wrong. 5x minus 3/5 x to the 10 plus 13/5. This is the only function that has both that derivative and that value. This last step with the value isn't going to get any harder. It's always going to be like this. But the step over there with the anti-differentiation, that could get a lot harder. Not so much for us now, but just in general. However, I think there's probably a question later that does do it. So let me just look. Because even in this class, that question could be worse if I just chose, yeah, that could be a lot worse if I chose a different function. Like I could have chosen, instead of, what were we on, 24? I think that's right. Yeah. So I chose one example of this type of problem. But you did a lot of these types of problems. And I could have chosen something that maybe had a chain rule in it, or a quotient that was a little more challenging. You saw some of these in your week 10 homework, I think. There's probably one on the final, the old final, like that. So they're not all going to be reverse power rule. Anyway, questions about this problem? I tried to do this one really in depth because I really want to make sure I mean, it would have been easy for me just to write down this equation and then plug in the value, right? But I really want to make sure everybody understands what's happening here, because this is related to a lot of things. I'm going to take a picture while you think if you have any questions. I'll take a picture so that I can post this. Most of us are here today, but what I'm hoping is that in my other section, people will ask different questions, and then you'll be able to see the work for those questions after, and they'll be able to see these. Okay. Now, I want to make sure we leave enough time for evaluation, so let me just calculate what that means. We're usually here from 9:15 to 10:05. And I wanted to stop 20 minutes early. So that's 9. I'm so bad at arithmetic. 45. That's not so bad. So this is the time when I want to start doing course evaluations in the attendance quiz right here. Don't let me forget that. Okay. Any questions about this? Okay. So let me take this off here just so I don't keep looking at it. 33, 39, 37. In question 33, you have a question about how to sketch the graph based on the sign charts that you find. Oh, that's a description of just the whole problem. Okay, let me start with 39 and 37 then, because those people, well, I guess all of these are like, I don't even know how to start. So let me just tell you how to start for each of these, I guess. Each of these questions were just about like, you know, how do I even begin? Okay, so instead of doing one of them for a long time, I think I'll just talk about how to begin for each of them. So for 33, again, remember that every one of these questions comes from something in the book, and you can actually find what it is. Like right there, it says 3.3.0.056. That means it's actually in section 3.3, problem number 56 in the ebook. That's where this came from, right? So you can go to the ebook, you know what section to look at to review this is section 3.3. Section 3.3 is, I think, the second derivative curve sketch. No, it's the, oh, that is F prime prime. I had trouble reading that, but this says F prime prime right there. So this is from that curve sketching part 2 week, which was week 12. So you can go back to week 12 and there's videos there. There's other homework problems there. There's examples in the ebook that are like this. So I'm not saying we're going to do that now, but I want to show you what to do when you're working on these and you don't even know where to start. You have so many breadcrumbs. So I said this out loud earlier, but maybe I should do it again. So again, this is section 3.3. Maybe I should actually just show you what I'm talking about. So you see section 3.3 is right here. And then you can say this is definitely this sign charts and curve sketching thing. Now this was question 56. We may not have asked, oh, but we did. This is actually a question from a previous homework. So we've done this question before and there's something about it here. And there's this nice video here that walks you through how to get started with that type of question. So then what you would do is you would take this question and try to like write it down on a piece of paper, try to solve it while you watch that video, you know, like, and pause, and that'll help you get started with that. Now, how to do this actual problem. What you need to do is that each number line gives you information about the function itself. So the first number line here, the one for f up here at the top, we see that something goes wrong with f at 2. So maybe it's an asymptote, maybe it's something else, maybe it's a hole, we don't know, right? Something weird is happening. Function is not defined there. And what are the pluses and minuses on this first number line? What are they telling us about the function? Not so, that's this one. That's very tempting though. I was kind of hoping that you would fall for that. So this is a good answer, okay? But that's this one. So let's go over here. This one tells us, because it's f prime, it tells us that the slope of f is positive, negative, positive, positive, which means f is increasing, decreasing, increasing, increasing, okay? But what does this one tell us, the first one? Well, it tells us it's almost like min and max. Positive or negative literally means positive or negative. to me, this is the hardest one, even though it's the stupidest one, because it's labeled with F right there. Right? What does it mean when F is positive? Well, it means that F is positive. Right? What does it mean when F is negative? It means F is negative, meaning below the x-axis. Okay, so that first number line is telling you where the function is below the x-axis and where the function is above the x-axis. The second number line is telling you where the function is increasing or decreasing. And what's this third one telling you? Concavity, yeah, concavity. Tell you F is concave up, and then concave down. Now, in the book, this question was not a multiple choice question. You just had to sketch the graph. And I recommend that you actually try that. Like instead of, looking at these graphs and trying to eliminate them and find one, you can actually sketch the whole function from this. And that's really good practice. So don't look at the choices and just see if you can sketch that, given the information that you have. Remember the thing we did with the arcs, the 4 different types of arcs? So like, for example, going up to -3, the function is going to be under the x-axis. It's going to be positive. We don't quite get to here. Sorry, the derivative is going to be positive, so the function will be increasing. And all the way up to -3 here, the function will be concave up. So in that first little chunk, the function should be negative, increasing, and concave up like this, but under the x-axis. And ending in a root here. These are actual bona fide roots of the functions, -3, 0, and 3. That's why they're on that number line. Okay. And when we're talking about maximum and critical points, this one right here is going to be a minimum of the function right there. And there's no inflection points. Anyway, I recommend, you can solve this WebAssign problem by picking a graph, but I recommend actually graphing it because you'll learn a lot more and then you'll be able to do a lot more other problems. Questions about that? Okay, so question 9, 39, and 37, you just want to know how to even set it up. Let's see. So 37. And setting up's the hard part. Like, I'm not surprised that that's the part people want to ask about. I wish I could draw right on that, but I can't. Well, I can, but an irritating thing would happen. I can actually lift the screen up and then it would be projected here and I could write on it, but it would shine a light in your eye, like it's reflective. So I don't want to do that to you. I'm just going to copy it over, this kind of situation. And what I should have done is not draw anything here because the whole point is that we don't need fence here. Okay? And the part where we need fence, we got these prairie dogs. One corner has a habitat with an opening, and we want to put some fencing. So our fencing is like this. This is, I don't know why, but it makes it easier for me if I make it look fancy. And I also remember not to put any in that spot. Okay. Now, I don't have any, no, this has a roof or something. It's not involved. Okay. I don't have any letters. I'm supposed to do a math problem. I have a diagram. It's not labeled at all. So the very first thing you have to do after drawing a diagram, they were nice enough to draw it for you. But the very first thing you have to do after that is you need some letters, right? If you're going to talk about perimeter, area, you need to have some labels. So what should I label? What geometric things on this diagram do I care about? Do I care about this? No. What do I care about? This length and this width. I don't know which to. Let's call this length, I guess. And then, and we'll call this one the width. You want to make up some letters? What letters do you like? X and Y, L and W, A and B. X and Y, you get to pick. Now, for my sanity, I always try to remember to make Y the thing that I drew vertically and X the thing that I drew horizontally, just because I'm so used to that. And I've noticed that if I flip that, sometimes I make a dumb error later on. Okay, so how much fence is there? There's Y fence here. There's X amount of fence here. There's Y fence here. How much fence is here? X minus 20. So this is probably enough to get you started with the problem. Maybe, well, I can go a little bit farther. We know that the area is what from this problem? Can you read that? It's very tiny. Yeah, the area is 2,500. What's the formula for area based on the letters that I have here? X times Y doesn't include this weird hutch, whatever that is. By the way, I have actually no idea whether prairie dogs have a nesting hutch, or I don't think I've ever seen any prairie dogs, but this is what I imagined would happen in a prairie dog situation. Hopefully that's accurate. Yeah, I hope so. And then I don't have a problem to do yet. What's the problem I have to do? What am I trying to find? Minimum amount of fencing. So how much is the fencing? I could write perimeter, but you know, really we're talking about the perimeter that's made of the fence. So what is the, I'll call it, P. Okay. And what is it? X plus 2y plus another x minus 20. So it's like 2y plus 2x minus 20. And that's what I want to minimize. Okay, so that's the setup of this problem. And then, as usual, you want to use this constraint. This thing here is the constraint. And this thing here is what you want to minimize. So as usual, you want to use this constraint to get this thing you want to minimize in terms of just one variable. And now it's just an optimization problem. Take the derivative, set it equal to 0, number line, first derivative test. Find a place where the fencing formula has a minimum. Well, I can, but do you really, does anybody else want to see that? You want to see that? How you deal with the two letters? Oh, well, okay. Let me do that part, and then you can tell me whether you want me to go further than that, okay? I'm happy to. What happens is with X and Y, I don't know why I made it red, but this isn't the same idea, so I'm going to make it a different color. This thing here, I can use that to kill one of the two variables. I'm going to kill the Y. So if I solve for Y, it's 2,500 over X. I'm sorry, I did that in a way that maybe you can't see it. Put 2,500 over X. And then I can put that into this Y. So I don't know if that answers your question, but right there. So I can use this to find Y in terms of X, and then I can plug that in there. And now I have an equation that's completely in terms of X. And that's a problem I know how to solve. I'm going to take a picture of this just in case this is helpful. I would take the derivative, set it equal to 0. And for some reason, I can't log into my phone and talk at the same time. Sorry. I would take the derivative, set it equal to 0, and figure out where this P function has a minimum. Now we are at the 9:45 mark. I don't want to go over that. So, but on Piazza, you can come to Piazza anytime and ask these questions. As you know, I'm there all the time. I will answer you. So yeah, so let's move on to this. I want to make sure everybody gets their points. So first of all, you're here. Thank you. Go to the assignment. And for the Wednesday double attendance bonus, so I know that you're actually personally here. Why don't you tell me what your favorite animal is today in your homework bonus, okay? So go to the canvas, and I'll show you where that is. Right here, Wednesday double attendance bonus. Click on that. You get 10 points. for letting me know what your favorite animal is. I could use cheering up today. It's good. It's always good to hear about people's animals. And I'll give you a minute to do that, and then we'll do evaluations. It doesn't have to be your favorite animal, you know, all the time. It can be like your favorite animal this morning. I think you should be free to change that. That's actually a really liberating thought. Instead of being like, well, I'm a, you know, dog person, then on Sundays be like, no, today I like giraffes. That's what I like today. You know, new day. I'll have to remember that. Okay, so that's your free points right there. On Friday, we'll have a study guide homework bonus. So if you finish 40 or more, no, 20 or more problems on your 40 problem homework and come in on Friday, give you another 10 points. Okay, I believe in rewarding you for doing the things that help you. Okay, so I think those things will help you. There are 2 evaluation type documents in this course. One is this first thing here that says blue course evaluation, and the other one is this course reflection. So you just did this double attendance bonus. This happens on Friday. Your blue course evaluation is in the sidebar, and I'll talk about that in just a second. There's a separate thing that I do not want you to do right now. I want you to do it later. Okay, but I want to show you what it is. This is the thing that's due on Sunday. So on Sunday is the final course reflection, and this is anonymous, so I won't be able to see your answers or even you know, whose answers are whose. I will be able to see your answers. Like when it's all done, it'll let me download a spreadsheet that has all the answers, but I won't be able to see where they came from. Okay, so this is anonymous. And it's kind of long because I really want to know about how you feel about different things that happen in the class, like how does Piazza work for you, or, you know, how do the homework resource pages work for you? And for each one, I'm looking for you to actually sit and think about this question for a couple minutes. Not just say like, it was fine, but like really think about it and then write like 3 or 4 sentences. Don't do that now because it's too much typing. You don't want to do that with your thumbs right now. What I want you to do right now is the official JMU course evaluation. So what this evaluation is every faculty member in the department has the same form, right? It's not questions that I made up, it's questions the department made up. And they're used to evaluate each faculty member as they come up for tenure or promotion. I already have tenure. I can't even be promoted anymore. So I don't need it for that. But what I need it for is to learn how you felt about the class and what your experience was in the class. Please take the time to actually write comments. If you leave a rating and there's a place for a comment, even a short sentence, because if you say like, if it says, how do you feel about the website for the class? And you're like, you know, good. That doesn't tell me anything. If you say poor and you don't say why, I don't know what to fix. Okay. So I want to know, what do you like? What do you want me to fix? Okay. Okay, so anyway, if you click on this link, the blue course evaluation link, I don't know what happens if I do it. That's confusing. It came, look at this, it made a second window inside that has the same stuff. That's very stupid. Anyway, click it in the sidebar. That'll work a lot better.